good morning, everybody. We're going to be doing some practice problems going over yesterday's topic, which is exponential applications or word problems. So this is TEKS 9C, and then this is going to be a two-part video. Part 1 you're going to do today, and Part 2 you're going to do tomorrow. So this is going to be Part 1. And then before we get started, I want to remind you guys those formulas that we learned yesterday. So remember, for growth, it was y equals a 1 plus b to the x power. Decay was y equals a 1 minus b to the x power. And then our constant, which is y is equal to ab to the x power. Remember that A stands for, so let me change my pens. A is the starting value. B is the rate, and remember we have to always change it into a decimal. And then X is time. Okay, so what I'm going to do is I'm going to do the first 3 with you guys. So I'm going to do the first 3 with you, and then you're going to do the next 4 on your own. Okay, so let's look at number 1. Number 1 says, find a bank account balance if the account starts with $100, has an annual rate of 4%, and the money left in the account for 12 years. So remember, first thing we do is we go through the problem and we label everything. So it says starts with 100. So that's our A value because A is our starting value. Has an annual rate of 4%. So this is going to be our B value. But remember, we have to turn it into a decimal. So that would be 0.04 because it's 2 decimals to the left. And then since this is talking about a bank account, if the money is not touched in that account, because it says money left in the account, then our account is always going to increase. So this is a growth. And then it says 12 years, so that's going to be our X. So first I'm going to write the equation, and remember our equation has both X and Y. So this is going to be Y equals A, which is 100. And since it's a growth, it's going to be 1 plus 0.04 to the power of X. Remember that we write our equation first, and then we plug in X to find our answer. So now if I plug everything in, so this is equal to 100, 1.04, because I just added 1 plus 0.04 to the 12th power, since that was X. And then if I type that into my calculator, let's see what we get. So 1.04 to the 12th power times 100. Okay, so we will get, since this is money, I'm going to round to 2 decimal places, 160.10. So having an annual rate of 4%, meaning every year they're going to give you 4% of the money that's in your account. After 12 years, you gained $60.10. So you started with 100 and now you ended with 160.10. So that's our answer. Okay, let's look at number 2. Number 2 says in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? Okay, so first we're going to go through and label everything. So it says in 1985 there were 285 cell phones, so that's our starting value, that's A. And then it says the number increased, so that tells us it's a growth, by 75%. So that's our B value, but we need to turn 75% into a decimal, so it's going to be 0.75, 2 decimal places to the left. Then it says, how many cell phone subscribers were in Centerville in 1994? So since we started in 1985, I'm going to have to subtract 1985 from 1944 to find my x value. So 1994 minus 1985, that's 9 years. So this is our x. Okay, so first I'm going to write the equation. The equation, since it's a growth, is going to be y equals a, which is 285, parentheses 1 plus 0.75 to the x power. Then to find my answer, I'm going to plug in x. So I have y is equal to 285, 1.75, because I added those together, to the power of 9. So if I plug that into my calculator, so I have 1.75 to the power of 9 times 285. Okay, so we're talking about objects. We're talking about phones. So let's see. This is going to give us 43,871.98, keep going, all these decimals. So this is approximately 43,872 phones. So 43,872 phones, because we rounded up. Okay, so in 1985, 9 years ago, compared to 1994, there was only people that had 285 phones, and now 9 years later, 43,000 people have phones. So this was definitely a growth. Okay, number 3. Number 3 says bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only one bacteria, which can double every hour, how many bacteria will we have by the end of one day? Okay, so we're going to go through this and start labeling. So it says doubling here. This is our first thing, and this doubling tells us it's a constant, and doubling means 2, so B is equal to 2. So on yesterday's notes, I had you guys list another word for double. You could have put triple. You could have put quadruple. All those numbers that mean, so like doubling means 2, triple means 3, quadruple means 4. Those are the type of numbers that you're going to see when it's a constant function. Okay, then it says if we start with only one bacteria, so that's A, which can double every hour, how much bacteria will they have at the end of one day? So this is, since this bacteria is doubling every hour, we can't use one day as our x. We have to think of how many hours are in a day. And we know that there's 24 hours in a day, so this is going to be our x. So I'm going to go ahead and write my equation. My equation is y is equal to a, which is 1, times b, which is 2 to the power of x. So remember, this is a constant function, so we don't have 1 plus or 1 minus. Okay, now I'm going to plug in my x, which is 24. So I have y is equal to 1, 2 to the 24th power. So that's technically just 2 to the 24th power. So 2 to the 24th power, which gives us 16 million, my bad. 777,216 bacteria. So just after one day of cultivating, that one bacteria turned into 16 million bacteria. That's why germs spread so fast. Okay. Now you guys are going to work on number 4. on your own. Make sure you are labeling everything. You're telling me if it's a growth or it's a decay. And then you're writing your equation. Okay, so this is what you should have done for number 4. It says each year the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? Okay, so first I'm going to go through everything in label. So it says it starts with 128, so that's our A. Eliminated tells us that it is a decay. However, it says half of the players are eliminated. So this is our decay. And we know half is 1 over 2. But if we were to turn that into a decimal, that would be 0.5. So B is equal to 0.5. And then after 5 rounds, rounds in this case is going to count for our time because tennis tournaments usually don't last years or months or necessarily not a set point of hours either. It lasts in rounds, so this is our X value. Okay, so since this is a decay, this is going to be 1 minus. So we have Y is equal to A, which is 128, parentheses 1 minus 0.5 to the power of X. And then when I plug in X, we're going to get Y equals 128. 1 minus 0.5 is 0.5 to the power of 5. So let's see how many players are left after all 5 rounds. So I have 0.5 raised to the 5th power times 128, and I get 4. 4 players. So after 5 rounds, only 4 players are left. Okay, so that's what you should have got. Go ahead and work on number 5. Okay, this is what you should have got for number 5. Let's first read the problem. It says the population of Winnetka, Nevada can be modeled by P equals 6191 times 1.04 to the T power, where T is the number of years since 1990. What was the population in 1990? By what percent did the population increase by each year? So in this case, it's not asking you to solve anything. It's just asking you to answer those questions. So if this equation, so I'm going to rewrite it here, P is equal to 6191 1.04 to the T power. If this is representing the population in 1990, what did the population start with? So it's asking for our initial value, which is our A value. And we know our A value is always that number in front. So that means in 1990, there were 6,191 people. Okay, now it says by what percent did the population increase by each year? So all you have to do to find that percent is look at what it says after the decimal. So after the decimal, right here, is 0.04. But if we were to turn this into a percent, instead of moving 2 units to the left, we're now going to move 2 units to the right. So this becomes 4%. So the population increased by 4% each year. Okay, so that was asking for something a little different. So if you would have just read the problem, this was a really easy one. You just had to identify the rate and then the A value. Okay, go ahead and work on number 6. Hey, this is what you should have got for number 6. You have inherited land that was purchased for $30,000 in 1960. The value of the land increased by approximately 5% per year. What is the approximate value of the land in the year 2011? Okay, so let's first go through everything in label. So let's see. You purchased it for $30,000, so that's your A value. the value of the land increased, so this is growth, by 5%, so that's your B value, which we turn into a decimal, 0.05. What is the approximation of land in 2011? So we have to take 2011 and minus 1960 to find the total number of years. So 2011 minus 1960 is 51. 51 years, and this is our X value. Okay. Now we're going to write our equation. And since this is a growth, remember inside the parentheses should be 1 plus. So this is y is equal to our A value, which is 30,000, parentheses 1 plus 0.05 to the power of x. Now we plug in 51 in for x to see what we get. So 30,000, 1.05 to the power of 51. And let's see how much this house is going to be worth. So 1.05 to the power of 51. Okay. So let's see. I'm going to write this answer over here. Okay, so you should have got 361,224. We're just going to round up. So that's how much the property is worth 51 years later. So in 1960 they bought it for 30,000, and now in 2011 it's going to be worth $361,224. Okay, go ahead and work on number 7, last one. Okay, this is what you should have got. During normal breathing, about 12% of the air in the lungs is replaced after one breath. Write an exponential decay model for the amount of the original air left in the lungs if the initial amount of air in the lungs is 500 milliliters. How much of the original air is present after 240 breaths? So in this problem, it kind of already tells you that it's a decay because it says write an exponential decay model. That means write a decay equation. But let's go ahead and still label everything. So 12% is our B value, but if we write that in decimal, it's 0.12. Replaced, and this word decay tells us that it's a decay. Let's see. It says the initial amount of air is 500, so this is our A value. How much air is present after 240 breaths? So this is going to be our X, our time. Okay, so let's write our equation. So since it is a decay, it's going to be y is equal to A, which is 500, 1 minus 0.12 to the power of x. And then if we plug in x, we get y is equal to 500, 1 minus 0.12 is 0.88 to the power of 240. So this is going to give us give me 1 second, 0.88 to the power of 240. Keeps messing up my calculator. 0.88 to the power of 240 times 500. Oops. Okay. So we get a very small number. So we get 2.37 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the negative 11. Okay, remember we talked about this a long time ago. What that 10 to the negative 11 means is that there are 11 zeros before that 2. So this is 0.0000, lots of zero later, 237. So this is a very, very small amount of breath that is left after 240 breaths of original air. Okay, and that's it. If you have any questions, please email me.